Hello, and welcome to the Executive Insights podcast powered by AWS. My name is Mark Schwartz. I'm an enterprise strategist with AWS. And with me is Jim Howitt, the VP of Amazon Software Builder Experience. Jim, could you start by telling us a little bit about your background and your role at Amazon?
Hello, Mark, and thank you. I've been working in the software industry for about 30 years. I've been leading platform and software enablement teams for about 15. Some of the leading companies and largest customers of AWS in the world. My job at Amazon essentially is to make it easier for all of the software engineers that build the software of Amazon, retail, AWS, Prime Video, others. Make it easier for them to build, deliver, and operate software for customers.
This sounds like a pretty big mission.
It is a very big mission. We have tens of thousands of engineers. We have hundreds of millions of customers around the world. But the ability to have all of those teams be able to innovate faster. And if you think about the impact of having thousands of teams being able to innovate faster, is tremendously rewarding for us and for what we can do for Amazon and its customers.
Wow, that's amazing scale. How do you justify the investments that you make in improving the builder experience? Is everybody on the senior leadership team aligned behind investing in these things?
When we created the organization, our leadership team was on board and very interested in improving the experience. Based on the anecdotes that they had heard from their teams, they wanted us to be able to go faster, to go better. And they challenged us to go off and commence in that mission. We were reporting double-digit improvements in many numerous aspects, from how quickly people can get started on work, to how often they were bringing software changes to customers, to reductions in manual work, to improvements in safety. And about a year and a half ago, after we had gone through continuously improving, we got an interesting question. It was like, these are all great. We're very happy to see that. But what do we get from that, from Amazon as a business, so that it can help us in the investment level of decision and really understand how do these improvements in experience translate to value for our customers?
That sounds like the CXOs I know. Yes.
Yeah. It's a question that I have heard prior to work at Amazon. It's one when I speak with other customers, they have that question. And it's people believe it's good to improve the experience of engineers and let them do more. But then how do you compare that side by side of other investments you made?
Sure.
So we took that challenge. We went back and we wanted to look at how do we answer that. And one of the lucky points is working at Amazon is we have lots of inspiration to draw on. And we found that years ago in our retail business, the challenge of how do we bring goods to customers was one. How do we improve that? And our retail business at Amazon developed a metric called cost to serve, which captured the entire systemic improvements to every aspect of taking a unit that somebody orders and packaging it up and bringing it to their house. And we realized we could translate that to software.
So can you tell me a little bit more about what this metric is exactly? How do you calculate it?
So at the highest level, cost to serve is the cost across all of your development efforts, your development tooling that it took to build and deliver software for use by customers over the amount of units of software that you delivered for value to your customers. It is a system level metric that looks at the totality of value that a team has delivered and how are you applying improvements to make it better. The goodness of the cost to serve framing is that it measures the quality of the system. So anytime you take friction, sources of delay, sources of loss, sources of defect out of the system, you essentially reduce the cost to serve. So if you bring products to people sooner, you reduce it. If you eliminate defects and returns or reduce them, you reduce cost to serve. We realize software, which is complicated and has everything from planning to design to development to operations, had some very similar fundamental concepts. At the end of the day, an engineer wants to build something that creates customer value. So your units are the code that you build. You package that into applications or services, and the value is realized when customers are actually using it. And we looked at the overall system and said, anywhere we can take defects, delays, friction, waste out of the system, we give essentially teams back more time to innovate for customers.
That's really interesting. So cost to serve encompasses all of these aspects of delivery, essentially. So it's like the ultimate metric in a way. Are there things it doesn't measure?
There are lower level things that it doesn't elevate to the top level surface. So like all complex systems, we measure we have metrics, dozens of metrics across different components. But when you bring it at the top level, cost to serve will have both output and quality. If you have a reduction in quality, your cost to serve will essentially go up because you have to do rework. If you have a team that gets into an unhealthy state and you have people leave, you've got to bring more people on board. So it actually helps you correct for that because it'll show your cost to serve will go up, where if you keep the team happy and healthy, your cost to serve goes down. If you let your technical debt get out of control, you're going to slow down as well. So it's got good control structures. But that being said, since those are only recognized as second order effects, what we do is we bring tension metrics up alongside cost to serve so we can take primary concerns and elevate them for attention. One of the ones that we look at is the sentiment of a team. So you want to make sure as the team is enabled to do more, they're also feeling happier. We find in our surveys that teams that feel like they can get work done for customers regular and often actually are happier, which doesn't surprise me because people come to Amazon because they want to create impact. Another that we look at is making sure safety. So we look both at the security coverage of our software and risks, and we look at the availability impacts of releases. And we want to show that as you release more software, your availability and events that are happening are getting better and not worse. And as you're releasing more software or you're doing more work, your security is getting better. And we're happy that we've been able to both increase what teams are able to do in tandem of improving safety.
So I guess this helps with the classic problem where if you define a metric and use a metric, people find ways to game it. Is this tension metrics essentially work against that, right?
The power and cost to serve, and we discovered this as we started to dig in, is the value comes in year over year improvement or quarter over quarter improvement. So if you're a team that is releasing software on a weekly basis and you go, well, if we do it daily, we release in smaller pieces and our cost to serve is lower, that's good. But the value is as you go quarter by quarter, year by year, if your team is getting better, if they're reducing defects, if they're reducing outages, essentially they're just going to reward off that baseline. And as they improve as a percentage, they're generating value. So there's a built-in safeguard against that. Similarly, if you have a manager that pushes the team too hard, says don't worry about technical debt, or the team just gets burned out, the systems will slow down, people will leave, they'll have to bring them back on board, and it's a correcting factor, so it captures that. So one of the wonderful discoveries we saw, there's built-in resistance. And then when you add the tension metrics and you expose additional data to people, you can help them focus on improving the goodness for teams.
I see. So this sounds kind of magic. Do you actually use this?
We started using it last year to prioritize our investments. And then in the last year, we started to also use it because we can translate the value you get not just into dollars, but into effective capacity. And as leaders came and say, how can I help my team do more? We can use this to show if you adopt these techniques, these technologies, you give your team effective capacity to do more of what they want to do, which is their roadmap and the features and capabilities they want to build for customers. And we're now seeing teams bring that into their planning. One of the joys and challenges of Amazon is how do you bring data to teams where they work so they can make decisions. And we believe in our teams being owners. So if you give them data in an easy fashion, they can make decisions. And if we also give data sets and guidance to our leaders in the company at the director and VP levels, that these are the things you can prioritize for your team so you can get more capacity and your teams can do more. And it allows them to create space or help prioritize some of those investments as well.
So this really empowers the teams, and that's pretty amazing with so many teams. So a lot of our listeners to this podcast, viewers, they're leaders of large organizations. Do you think this is something that can work for other organizations besides Amazon?
We do think it can work in part. Amazon has teams that work in retail. We have teams that work in hardware. We have teams who launch satellites into space. We have teams that do cloud services and foundational models. So we cover a broad spectrum. One of the things that we found in our research is the most important influencer on an individual developer's experience and productivity is their team and how their team builds and ships. And we found in different business divisions, different technology types, people build and ship differently. And what we allow in cost to serve is you can plug in the model that your team uses. Each of those teams can say, this is how we work. We plug this in and we want to see how we improve. And that allows you to not just take an odd new metric, but to take the way you're working and plug it in and show value that's based on how you deliver value for customers.
It's interesting. You framed a lot of things in your answer there in terms of teams. I think we hear a lot of questions about developer productivity these days, but you seem to be looking at it from the perspective of teams rather than individual developers. Am I getting that right?
One of the things I'm most proud of that we do is that we not only did we foundationally believe that teams were the unit, but we did the science research over 5 years of data. And we found that how the team ceremonies, how they ship, how they work are the biggest predictor of an individual's productivity. So that led us to focus on how do we enable teams to make the right investments, to use the right tools, to make their lives better. And then that rising tide lifts the boats of all members on their team. From that perspective, individual performance is something between an employee and their manager, but developer experience is a team sport. And if you can help the team play on a better field, they can give them better equipment and tools, they can do better.
What are some examples of changes you've made to the developer experience to improve the cost to serve?
One is making it easier for teams to bring their software to customers, which is the build and deployment process. So we did a lot of investments in deployment safety and deployment automation. And that's had two effects. Is one, it's enabled teams to just be able to bring software to customers more easily by doing less work, but having safety improve. They actually have more time to go back and build the things they want to build. So from that, we've seen both software gets to customers faster. Software takes less work to release the fact. And we've actually watched, as a result, teams are able to release more changes to customers as they move along. The second area is we've looked at different types of abstractions and templates that we can give them so that essentially instead of building everything from scratch, you can grab a template, golden path off the shelf, get started, and start building from that. And if we know that some of these templates actually are easier to maintain, or we can centrally manage and patch them on behalf, then you can spend more time building on your differentiated work. And in the last few quarters, with the rise of AI, topic on things, we're seeing it growing in its impact, in its effect to cost to serve. And what is very interesting about AI is there's been a lot of discussion of lines of code and how many lines of code did the AI do. Lines of writing code is just one of many jobs to be done by engineers because cost to serve is a system metric and it captures the entire experience. If you use AI to help you find information, resolve defects, diagnose problem tickets, go through logs, all of those benefits start to roll up. And as we're bringing AI into more places, we're helping builders and more of their jobs to be done. And it's reducing cost to serve. So we're excited about where it will go.
Yeah. Before I ask you a little more about AI, there's one thing that's bothering me in what you said, or worrying me. I once was a software developer, and I've led software development organizations. And I don't know, my perception is that developers are pretty opinionated. They want their tool chain, they want their deployment process that's their favorite. Do you mandate what process they should use? How can you get these cost to serve improvements without having control over what they're doing, essentially?
You are correct in that engineers like to pick their tools.
They do.
And we drive our decisions by a mixture of anecdote, data, and expert judgment. And our anecdotes come from many from surveys and user research. And the ability to pick your tool is one of the key aspects of autonomy. So the way that we combine giving people choice and helping them reduce is we take the most common tasks, patching software, deploying across dozens of regions, doing security scans, maintaining large code repositories that teams could do, but it would take a lot of time away. It's the work, that's what we call low differentiator, undifferentiated work.
The toil.
And it's toil, but it's also just, it's not the things that's going to differentiate your value to customers.
Right.
And we provide those to our teams to use. And then they pick additional tooling on top of that makes them effective. And that combination, we can tackle the large section of undifferentiated work. They can tailor things as needed. And we have so many teams that some will have specialized needs. And where we bridge the gap is we do provide guidance to people. And you say, if you want to use this template, you can go faster. But if you have unique needs, you can choose your own. But we share, like, teams like yours who do things like this get capacity back.
All right, now to the important topic, AI. What's happening? I guess it's changing the way software is developed in a big way. What kinds of changes are you seeing? What do you expect? How do you think it's going to affect the developer experience?
We've seen a pretty significant evolution in the last 18 months, and the pace of change is increasing. So early on, we saw a lot of autocomplete type work. Last year, our team did a lot of work of using transformations to enable teams to do large scale upgrades, language upgrades. So instead of them having to do that, we used AI and tools to do that for them. A famous example we use is our JDK 17 upgrade we did last year, where the average team had 58 separate dependencies, and it would have taken them weeks to manage through them. And we use AI to essentially reduce that work to just a day for folks and realize a lot of benefits. So in the last 6 to 9 months, as agents have really taken off, we've started to see new patterns of work, which essentially were people would give a task, they would describe what they want to the agent. It comes back, they look at it, they say, I like this, I don't like that. They give it additional instructions. So they're still an engineer. They're now auditing, critiquing, and improving instead of learning a new language, learning how to do, doing kind of more of the repetitive configuration changes and the like. So some of the examples we've seen is people can learn new code bases faster. They can make improvements to code bases that they don't know that particular programming language. We found usability, accessibility improvements can be done very quickly. And part of the things that we do as a company is we've opened up the space to experiment. So we've had some pioneers who wanted to share their ideas, and part of ASBX we did is we gave them a large platform, live streams, video sessions you can play back, knowledge series to share that knowledge. And we've now seen that picked up by 20,000 plus people in the company, like in one single channel. And we now have tens of thousands of people who are now riffing on those experiments, sharing new ideas. And then we look at those best ideas and we bring them into our products.
How have the developers responded to it? Do they enjoy working with AI?
Every month, we talk to a few thousand of our engineers and we ask them, what do they think? And the 3 things they've told us is they save time, they feel more productive, and they'd be unhappy if we took the tools away. When you have anecdote and sentiment and data all going in the same direction, that's a good sign.
I love that example of the JDK upgrade because there's nothing more boring than doing that kind of work, right?
Exactly.
I
Yeah.
could imagine the developers would love having some relief on that.
It's upgrades, patches are fun the first time you do it because you learn how to do like high grade professional software. The third time you do it, they become toil. But there's something you always have to do. Your phone is always updating new apps. So making that go away. And we're looking at ways within our ASPX to make more and more of that go away because then you just spend more time on the innovation you want to build.
And how do you think Amazon Kiro will affect the developer experience? I think you've got some developers who are using it now, right?
Products like Kiro and the broader agentic products have a very big aspect of developer experience that's more than just lines of code, and the ability to help developers in all those jobs to be done will let them basically be able to take more of their ideas to customers faster. And what we're talking about today of cost to serve is that encapsulates the whole system and how do you improve and reduce friction and make things faster and speed getting answers in the entire system of the jobs to be done for developers.
So, Jim, to close things out, could you tell our audience maybe three important lessons that they can learn from what we've been talking about?
The first I would say is that you can improve developer experience in all of its complexity and demonstrate business value that your C-suite can see. That can be done and without sacrificing the experience. The second is that value you can use in three different ways. Simple dollar savings, return on investment to plan your investment, or my favorite, capacity that you enable teams to innovate and build more. And third, you can start small. You can start with a division or a team. You can start with existing frameworks you're using around velocity and plug them in and start to recognize value and use that as a flywheel to generate value and encouragement in the rest of your company.
That's great. That's great advice on how to actually transform an organization using a metric like cost to serve software and by improving the developer experience. So thank you so much, Jim, for being with us and for giving all this helpful advice.